In the last session, we discussed about the last object-oriented programming concept, data abstraction, and we have seen what is data abstraction and how we can achieve data abstraction in Java. So through interfaces and data and abstract class. So we have seen examples on that, and we also discussed the differences between abstract class and interface. So in this session, we'll discuss about, so that actually concludes the object-oriented programming concepts. And in today's session, we are going to discuss about something called wrapper classes. So till now, we worked with primitive data types like int, double, float, right, char, Boolean, right? These are the primitive data types. And, you know, we can store the data according to the data type, but we need more than the primitive data types for storing the data for collections, right? So what are the those data types is, so derived data types. So data types, these are called as primitive data types, and there are something called derived data types like array list, list, array list, hash map, hash set, and so on, which comes under collections. And we will discuss that in the coming sessions, but those are called as derived data types, and they actually store the objects. So they actually store the objects instead of primitive data types. So they only support objects, right? So when we wanted to work with collections, so these primitive data types are not sufficient. So we need to actually have the everything in objects. So then how do actually we use this primitive data type? Say, for example, I have to store some numbers in a list or in an array list. So how do we store it, right? So say, for example, I wanted to store some 10 numbers, integer numbers. Today, we know we can do it using like this, right? So we can create an array and can store 10 numbers, right? But how about like this is like this again, like we are storing 10 numbers of primitive data type integer, right? But when you wanted to actually store something called objects into your collections, like into collection objects like, you know, array list, hash map, linked hash map, like that. So we need objects for that. So how do we actually store the objects then? So these numbers can't be stored directly, right? So how do we actually store them? Say, for example, there is an array list. So this is the syntax of array list. And if I wanted to store integer values, right? So we can't directly store the integer values. That is a primitive data type, right? So this array list is one of the collections, and you can only store the objects. You can only store the objects, but we do have the primitive data types. So we need to convert these primitive data types into objects. So each primitive data type has its own class associated with one class. So int has a class called integer. Float has float. Float is a class. Double has class called double. So what do we mean by classes? We can create an object for that. We can create an object for that. So for Boolean, we do have Boolean class, right? So these are the wrapper classes. We say these are the wrapper classes on top of the each primitive data type. So what is the use of these wrapper classes? So we can actually convert these primitive data types into these objects using these wrapper classes. Say, for example, array list. If we wanted to store integer values, then it can't store the primitive data type, right? So we can declare something like this to store the integers. So this actually allows us to, store the integer values, integer array list, which is used to store the integer values, right? So integer here is a wrapper class for int data type, int primitive data type. In the same way, if you wanted to store the other primitive data types, we have to provide the its associated wrapper class. So these are the wrapper classes. So wrapper class is used to convert this primitive data types into the objects. So as we are calling these as classes, so when we have classes, we can create objects, right? So these are the wrapper classes, and using these classes, we can create the objects. So that's how we're gonna convert the primitive data types into the objects. And using this wrapper classes itself, we can do the reverse of it as well. So if we do have these objects, then we can convert them into the respective primitive data types as well. Say for example, I have some integer object. We can convert them into the respective integer primitive data type also, right? So using the same wrapper class, we can convert the primitive data types into objects and also objects back into the primitive data type as well. So using the same wrapper class, we can convert primitive to object and also object to primitive. Now let us see, how do we do this? Let's take an example and let's understand how do we do that. I'll create a package. I'll call it as J17. We'll create a new class. We'll call this class as, this is wrapper class, right? So let's call it as wrapper classes. Cool. Now, what we usually do for primitive data types, we declare a data type, right? We declare a data type. We'll just say int a equal to 10, something like that, right? And if I wanted to have double, right? So then what do we say? Double d equal to, so say for example, some 5.8, 8.1, something like that, right? Char. And we do have Boolean as well, which can be true or false, right? So these are the primitive data types we know. These are the primitive data types, right? So now, how do we convert these primitive data types into wrapper classes? So first of all, these are the primitive data types, and why we wanted to convert these primitive data types into wrapper classes? So collections, right? So the derived data types only supports the objects, working with objects. So we wanted to convert these primitive data types into objects, and to do so, we can use the wrapper classes. So let's see how to convert these primitive data types into objects. So you just need to have integer. Integer is a class, right? So we can create integer object and then just assign the value here, integer value here. That's it. So it automatically converts this primitive data type into the object of integer class, right? So a is a integer of primitive data type, which with this statement, it converts it into the integer object. So is an object of integer class, right? Again, integer is a class from java.lang package. So this is the reason we are not importing any package here, right? On top, we are not writing any import statement. So it is coming from java.lang package. and IOBJ is an object of integer class, which is storing the integer parameter in it, right? And this is called as autoboxing. So automatically converting primitive data types to object type is called as autoboxing. And in the same way, like we can convert the other primitive data types as well. Say for example, double. Just assign it something like this, then it will automatically convert the primitive data types into the double. For Boolean as well. So for Boolean, we do have a class called Boolean. Uh, so this automatically converts. So with these statements, you see, all these are the different classes, right? Each one is one wrapper class. So which was actually created for one primitive data type. So integer class is for integer primitive data type and so on, double, character, Boolean, right? So each of these are classes. So if you observe the difference, so even the color is also different, right? So it's like a keyword. Primitive data types are like a keyword, and you can see these are the classes. And how do we identify them? So the first character is the uppercase, right? So these are the classes. Actually, we can create objects for these classes, and we can assign the primitive data type directly to this objects. So this is called autoboxing. Converting the primitive data types to objects is called autoboxing. Right now, let's print this statement. So we wanted to print this objects and verify. Double, this is character, and this is Boolean. And we can see clearly, right? So the primitive data types, we are not actually trying to work with primitive data types here. If you observe, I'm not displaying the values of the primitive data types here. The primitive data types has been converted to the objects. So has been converted to the objects using the wrapper class. So these are the wrapper class objects. We converted the primitive data types into wrapper class objects, and we are displaying them on the console. And you can see these values, right? So this is how we can convert the primitive data types to objects. So once we convert this to primitive data types to objects, we can use these objects in our collections, right? So collections are the another data structures which we use to actually store the data and manage the data, right? So these primitive data, you can't directly use them. So we convert them to the wrapper classes. So we convert the primitive data types to objects. So objects of wrapper classes. And how do we, so this is how we can convert. And when we are converting primitive data types to objects, we call that as autoboxing, right? Now, we can even convert these objects. Say, for example, for some reason, you have these objects, right? Wrapper class objects, and you wanted to convert them back to actual primitive data type, right? So in that case, how do we do that? Say, for example, I have something called some integer value. So I wanted to convert this. There is an object called integer object of wrapper class I object, right? I wanted to convert this into primitive data type. So how do we do that? So it's simple. The object we can directly assign it to the primitive data type. So this is called as unboxing. So converting objects to primitive data type is called as unboxing. In the same way, like if I wanted to assign double, so how do we assign double? We create a double object and then assign it. So this object has been assigned to the primitive data type, right? So this is how we convert the primitive data types to the objects, respect to object, char value, Boolean value. So this is about converting the objects back to the primitive data types. So we have objects, and if you wanted to convert them to the respective primitive data type, so this is how we can do it, right? We can actually create a integer variable and assign the I object directly to it. So there are some methods implicitly applied in it and how these are converted, but these are done implicitly. So this is the reason we call them as unboxing. So this is autoboxing. Converting primitive data types to objects is called autoboxing, and converting objects back to the primitive data type is called as unboxing. This is called unboxing, right? Char value and Boolean value, right? And you can see the output here, the last four statements, right? So we got the right output where we converted the objects to primitive data types. So the first case is converting primitive data types to the respective objects. And in case if you wanted to have the objects converted back to the primitive data type, so this is how we can do it. And this is called as unboxing. So autoboxing and unboxing. So interview question. This is an important interview question. What is autoboxing and what is unboxing? And why we require that? So autoboxing is required to convert primitive data types to objects. And why we wanted to do this is mainly we can't work with the primitive data types directly in the collections. So this is the reason we can't convert them back to the, we convert the primitive data types to the objects, right? And that's not the only reason. So we do have other reason as well, right? So say for example, let's go back. Say for example, I have something called int a equal to 10, right? So can I actually apply? So with this variable a, what can we do? We can actually store some integer value, fine. And we can even modify it. As it's a variable, we can modify it whenever we wanted to modify the value of a, we can modify it and we can, use it in wherever we want it. So whenever we use a, the value of a will be, used, right? Whatever the value at the time of a, that will be used, right? So can we actually apply or, say for example, you have something called double like this. So you can only use this double directly, like, right? So double is also like other variable, any other variable, and you can modify the value and you can use this value. But say for example, you have some string. String is an object, right? String is an object, and you can see here string s equal to Selenium. Say for example, this is the case. So can we actually use methods on this? So because s being class, so we can also use the methods which are all defined in class string can be used for its object as well. S is an object of string. So s dot, I can use length. I can use all the methods which are defined in string, right? So that's the main advantage of string. So if I have in the same way, like with this primitive data types, we can't do anything, right? So these are just the variables. Primitive data types are just the variables, right? But integer, right? So say for example, integer. In, if we have integer wrapper class like this, right? So then we can apply on this x. X is an object of integer wrapper class now. So on object, so we using the object, we can actually call all the methods which are defined in integer class, right? So there are multiple, there could be multiple util methods within the integer class defined. all those methods we can actually access using the object created on top of integer, right? So same is the case for double as well. Say for example, I have something called double, right? So in this case, I can use this object D to access the methods which are defined in class double, right? Same is the case for, we have seen string directly. So there are multiple methods defined in string, predefined methods. So we can use those methods within the string by creating an object for string, we have seen. So the same advantage will come for the integer and double or any other wrapper classes, right? Char, character, and Boolean as well. So that's another advantage. So we can actually use the methods of the wrapper classes. That's another advantage of having wrapper classes, right? So now we'll see. So these are the advantages, right? So we can convert primitive to object. So this called as autoboxing, and let me put it here, autoboxing and unboxing. Unboxing is object to primitive. And what's the advantage? We can actually use them in the collections when we wanted, when we convert primitive types to objects, we can use them in the collections. And also when we create an object for the wrapper class, we can actually use the methods defined in the wrapper class. Right now, say for example, I have some string. Let's take this string itself, right? Now, can I convert this string to number? So this is not a number, right? So we can't convert this string to number. So we cannot convert, right? We cannot convert this to number. Say for example, I have some other string where it shows up 100. So can I convert this to number? Yes, this is the number, right? So can convert to number. So we are storing, we declared integer, declared integer string object, but we are storing integer value. Still this is supported because string, what it says in double quotes, whatever characters you want, the sequence of characters, you can put it in the double quotes. So that becomes the string value, right? So what we are doing here, instead of the sequence of characters, alphabets, we are storing the numbers, right? So which is again a sequence of characters, and which is according to the definition of string, right? String value. So this is a string value, and we can, as we know, these are the numbers, so we can definitely convert this to number. This is a number, right? So we can convert this to number. This is supported, right? Now we will see what are all like how we can convert. See, string we can't convert to number, right? And string we can convert to number. And the same string, say for example, I have something like this. So can this be converted to double back? So yes, we can convert this to number. We can convert to number, right? So this being stored in string object, it doesn't mean it is string actually. So in double quotes we are storing, then this becomes a string. So this is stored as a string itself, but as we know, it has only numbers, and if we wanted to convert it, then we can convert, is my point. So we can convert this value to number if this is the actual number, right? So the reverse is not possible. If it is an actual string, if it is actually a sequence of characters with alphabet, then we can't convert that to a number because it doesn't have the numbers, right? It has characters. So characters can't be converted to number. But if you have the numbers in it, digit, then we can convert that to the number. So that we'll see now how we can convert. how do we convert this, right? So data conversion example. Is that clear? Autoboxing and unboxing. So we are going to other topic. How we can convert the string to other data types. Okay. So we wanted to convert from string to int, double, character, and also Boolean. We'll try all this. So first we'll see. Say, for example, so let's try even this. We wanted to convert this string to integer. Can we convert this? We can't convert, right? So it has a sequence of characters with alphabet. So this is not possible. We can't convert this. Cannot convert. We cannot convert this to number, right? So no, our target is taking string as an input and converting them to primitive data types, right? So the number data types or other data types like this, whatever we have specified here, right? So for example, let's take a number. So I'll take string number 1 is equal to, say for example, some 10, right? And I'll take another number, another string object where I'll have some other value, right? So these are the numbers. We know it's clearly digits stored in string format, right? But as we know, these are the digits. We wanted to convert this into the integer values or number values, right? So we can clearly see these are the integer values, and we wanted to convert this into integers. How do we do that? But these are stored in the strings, right? So say for example, if I do something like this, string num1 plus string number 2, right? So what happens? Say for example, we had this in system.out.println. We do get the concatenation of these two, right? So see 1020. This is not the addition, but we are expecting the sum of these two numbers. But these are stored as strings. So how do we do that? So in that case, what we can do is, so we can convert these strings to integers. So how do we convert? So for this, we use the methods of integer wrapper class, integer dot parse int of. So if you see integer dot parse int of, if I say dot, you can see multiple methods here, right? Which are supported or which are defined in the integer class. An integer class is a static class. So static class, as it is a static class, we can access here. These are all the methods defined in integer class, and all these methods are static. So being these methods static, we can call these methods using the class name. Class name is integer here, right? So integer dot, we are gonna call any of these methods. So we are calling this method called parse int of string number, which actually converts this number 1 into integer, right? In the same way, I wanted to convert second one also, second number. So integer dot parse int of string number 2, right? And I know the result will be string integer, right? So parse int integer dot parse int, what it does, it converts this string number, whatever you have passed, this being it stored as string, it is gonna convert it into integer, right? So Java doesn't know what you have placed it within the double quotes. It could be even sequence of alphabets as well, right? But as if we think that it's a number, then we can actually parse it, convert it into the number using this method. So what's the method? As it's an integer, we can use integer dot parseInt. ParseInt is a method which is defined in integer class. And as it's a static method, we can directly call like this integer dot parseInt of string. We pass the actual string, which we think is a integer, right? So with this, it can be converted into the actual integer, right? So same is the case for the other one. So both being integers, so we can store the value in some integer called sum, right? Now you can see the output, right? Sum of these two strings after converting them into the integer data types, right? And you can see when you hover on this method, you can see the signature of the method. So it is integer dot parseInt, and you can see integer is the return type. Integer is the return type, right? And you can even see, you can click on this. If you can click like this, you can just hold your control key and then just do a left click on this. So you can go to the actual definition of the method and you can see it returns integer. It's a public access modifier and it's a static method. So as being a static method, so we can actually call this with the class name. If you click on the integer, you can see integer is a final class, right, which is extending some class called number, right? Like, so integer is a class and parseInt is a method, which is static. So we called it like this and we converted the string. So we converted the actual, string. It's a string, but which actually stored the integer value. So we wanted to convert that to the integer. So we use this method to convert the string, which is actually storing the number. So we use this parseInt method to convert that number string to number, right? So this is how we can do it. We converted from string to we converted integer, right? So like in the same way, we can convert. So this is string to integer, right? Now let us actually convert string to double. String double one. Here, for example, I have something called like this and another string which also has double value. Now we wanted to convert this double values into the, so these are actual, so if you see these are strings, right? But we wanted to convert them into double. So as the values it contains are double, we wanted to convert them into the double. So how do we do that? Like the same way, like how we did it for integer. So what did we do for integer? Integer dot parseInt, right? So we can use the double methods here, double dot parse double of the actual string. And if you wanted to actually do the sum, again, like double dot. So double is another class, right? It's another wrapper class. So when you do dot, you can use all the methods defined for the double class, all the methods which are available for this double class, right? So parse int of, parse double of, right? String double two, all right. So this parse double is gonna return the double value, right? So we'll show it in something called sum. And we can see the sum of the double values, right? So if you try to do this operation without converting, what happens? It just concatenates thinking that these two are just the two strings, right? So what does string concatenation does? It just appends the second string to the first string and gives us the combined output, right? So that is not what we wanted, right? So we wanted actually the sum of the two numbers. So these are two are like numbers, right? Double values where we can actually sum up these two numbers. So we need to convert this to the first double value, right? So this being stored as string, we need to convert them to double first. So we use a method called parse double. So which is available in the class called double, right? So this is how we can convert from string to double. All right. Now we will see how to convert from string to Boolean. Say for example, I have some string and I'll store some value called true. So Boolean can either have true or false, right? It can either be true or it can be false. So how do we convert? So again, we didn't store it as a Boolean value here, right? Boolean variable. We are storing true and false also as string, and we wanted to convert this to Boolean. So how do we convert? Again, there is a proper class called Boolean. Boolean dot parse Boolean off. So parse Boolean off. Pass the string value here. That's it. This actually converts to Boolean. Yeah, it returns true, right? This is string to Boolean. So how do we convert a string to a Boolean? We use a method called parse Boolean defined in Boolean wrapper class, right? So Boolean dot parse Boolean of pass the string. So if it is a valid one, then you actually get the result, right? So say for example, I have something called by mistake, you must have written something else, right? So then in that case, when you execute, you get the result as false. By default, whatever value we have, that will be returned, right? So let's actually verify it for integers as well. Say for example, let's go back to this. We have sum, right? So fine. Now, say for example, I wanted to sum up two prices, right? So what happens in that case? Think these are two prices of two products, right? And we wanted to, and we know these are stored as integer as strings. So first being $10 and second being $20, and we wanted to sum of these two. So now let's observe. So you can see we get the number format exception because so this is not completely a number, right? So it has some special character in it. So Java doesn't know how to convert that into a number. So that's the reason it says number format exception. So when we wanted to convert any string to integer, it has to contain all the digits, right? So only then it can consider that as an integer and it can convert successfully to integer. If it has some, other characters other than the digits, then we get a number format exception, as we can clearly see here, right? While converting, it is not able to convert this string to integer, as it has seen some special characters here. Right, same is the case for double as well. So it has to have the only double values, right? If it has any other values other than double, and when you try to parse the double using the method double dot parse double, then you get an exception, right? For Boolean, it will be if you have any other characters, by default it returns false. So when it is not able to parse it, it will just return the false value. Now, when I wanted to convert string to char. So can we convert string to char? So let's try that. Here, for example, I have something called the character C, right? So I'll take character class dot parse. So do you see parse here? Parse char? No, right? So character class doesn't have parse char, right? So this is not supported. We can't convert those from any other type to character type. So as you can clearly see that. So for any other classes, we do have a method called parse, right? Parse and its data type, respective data type. But for character, it is not there. So there is a reason behind it, right? So being a single character, it can't be converted to any other types, right? So string. So we have a string. String is a sequence of characters, but char is only a single character, right? Char is only a single character. So this is not possible. Only this is not possible. From string to char is not possible. All others are possible in double and boolean, right? From if you have a character stored in string, so that can't be converted to a character data type, right? So this is a one scenario where we actually try to, so let's call this as first scenario, where we are actually converting string to other primitive data types. Now we'll see something else. Scenario 2, we'll see from int, double, boolean and char, we wanted to convert this to string. So can we do like this? Let's see that. So we do have a integer value, double value, boolean, and we wanted to convert this to string. First scenario we have seen, if you have a string, we can how to convert them to integer, double, boolean, primitive data type. Now we do have primitive data types, and for some reason we wanted to convert them to string, right? So can we do that? So let's see that. Say for example, let's start with the integer a equal to 10, right? Now how do we do that? Say for example, like I wanted to convert this string value. A is a string here, right? Sorry, integer. A is integer variable, and I wanted to convert this to integer. So integer A, I wanted to convert it to target string. So for all the examples now we talk, so this will be the source in the sense like we'll take a value of that, and the target will be string. We'll try to convert them to string. So how do we convert? String dot value of, so what's the value? A. I'm going to pass value A. So this is valid, and string dot value of A. So it actually converts this A value to string. So you can see value of is a method present in string class, which is actually converting this integer into string type. You can see value of the return type of it is string. So we can hold it in some string like this. So this is possible, right? And you can see the value here, right? So this is possible. Now, the same, say for example, I have some double value, right? From 12.5. Now, how do I convert this to string? Same, string dot value of, just pass the double value here. That's it. As it is again a string. So you can store it something like this, right? Yes, one. We just need to use the value of method and pass the double value. It automatically converts this value into string. So it creates this value, and it just converts it into the string type. Yeah, it converts, and we can see the value here, right? So same is the case for Boolean. String dot value of, pass the Boolean value. As it is written string, you can hold it in a string variable. Yeah, see, it returns true, right? So if you observe, in all the cases, what we are doing, we are just using the same method, string dot value of. So this is what we call it as method overloading. If you observe, string dot value of is the same method, which is present in string class. But if you observe, so we are using same method to perform different operations because we are passing a different data type as a parameter in every call, right? So first call we pass the integer value, right? So in the second call, value of method, we pass double. In third call, we pass Boolean, right? So in the same way, like we can even pass char. But if you observe, this is what we call it as method overloading. So it has been overloaded. Value of method has been overloaded to accept any parameter, right? Any type of parameter, but it is the same. Like the name of the method is same. The type of argument it is accepting might differ, right? So, but you can pass any type of argument, but the method name is same. You don't need to worry on that, right? Even see, for example, I have char value now. So how do I convert? I can use the value of same again. Cal string dot value of. So even if you see, if I do value of, you can see all the data, you can see all the variants of value of method here. See, value of method accepting Boolean, char array, double, float, integer, right? So this is what the advantage of method overloading is. We have discussed this, right? So value of method is overloaded here to accept any type of parameter. All right. So this is all about converting any primitive data type to string, right? Now we'll see, we have seen till now string to primitive data types and primitive data types to string, how to convert them, right? So now we'll see another scenario, like how to convert from one number data type to other number data type. Say for example, I wanted to convert from integer to double. So can we do this? Say for example, you have something called integer 10, right? And I wanted to convert this integer to double. So is that possible? I wanted this integer value to be converted to double. Say for example, I will do double D equal to A and will display D. So A value is 10, but I am assigning this A to double value, right? Double variable. I have declared double and there is no error first of all, right? So when I actually assign integer A to double, there is no error and we are trying to display it. Let's see. And you can see the value is not 10. So it is 10.0, right? Being a decimal number. So double actually stores the decimal number and you assign an integer value to it. So it has converted into the double of it. So 10.0, right? So that is how it actually stored the value of integer, right? So with this, we can say that integer can be converted into double, right? So integer can be converted into double value. But how did it display? It did not display the value as is. It converted into double. So double actually stores the decimal values. So has converted the integer value into decimal. And we can clearly see that it actually placed a decimal point and then a zero after that, right? Now let us try if we have double, right? And I wanted to convert it into integer value. So is that possible? So let's try that. Say for example, have something called 20.25, right? And I wanted to convert this into integer. So say for example, like how we did it earlier, let's do it in the same way. So D is already there is what it is saying, right? So for now, I'll just comment this out. Yeah, is this possible? So earlier we just did this, right? So we just wanted to convert integer to double. So we had declared a double variable and assigned the integer value to it. In the same way, we are trying to assign double value to integer. But now see, we got an error. See, red color cross mark, right? So if you mouse over on that, you can read the error. It says type mismatch, cannot convert from double to integer. You cannot convert from double to integer. Why? It also suggesting ID is also suggesting three quick fixes, right? So let's start with the second one. It says change type of x to double, right? So integer x to double, right? So change this to double is what it is saying. This we know as both are doubles. So it is saying it is an integer. I can't hold this double. So convert this x into double is what it is suggesting as per the second suggestion, right? This we know it will work. And what's the third suggestion? Change type of d to int. So, or change this to int is what it is saying. So even if you change this to int also, it is fine, right? So this value it can't hold, but we can, if you can change the value, then if it is both are integer, then one integer can hold another integer, right? So that's what the third fix is. But now coming to the first fix, read the first fix. It is saying add cache to integer. Add cache to integer. What does that mean? So what do we mean by adding cache, right? So if you see here, let's do it. Let's click on it. So the error is gone. The error has been fixed. So what it did, it is double value. But so explicitly you wanted to convert it into integer. So this actually is a possible loss of data. So this actually means a possible loss of data. So let's see that. Now, I wanted to display this integer value, where I actually stored the double value in it. So see, it actually displayed only 20 because integer is meant only to store the integer values, right? Double is meant to store the decimal values. So it was able to store this 20.25 clearly, right? So you can even verify that if you want, right? So see, double can actually display the decimal value, but if you actually convert that explicitly into integer, so first of all, automatically it is not converted. But if you try to explicitly convert it into integer, so this is how we can convert. This is double, I know, but please convert that into integer is what we are seeing by specifying this integer data type, right? Int keyword, right? In braces. So this is what we call it as typecasting, which we are going to discuss this in the next session in detail. But for now, you can think it of like, so this is a double, which automatically can't be converted into integer, but we can do it using the typecasting, but with the risk of possible loss of data. So you see here, you have a loss of data, right? So even though it is 20.25, when you convert it into, as it is double, when you convert it into integer, so integer can only hold integer value. So it only displays the integer value, ignoring the decimal value, right? So this is possible loss of data, right? So you have to be careful when you are converting from double to integer, right? So you might have the loss of data, possible loss of, I'll just mention it here. Possible loss, possible possible loss, possible, but with loss of data, right? So yeah, is that clear? Understood? Okay. So integer, integer is a data type, right? So integer, where we have the some integer values. So this can be held by double. Double is a where we can store the decimal values, right? Double can store the decimal values. So integer can fit in double, but double double is a decimal value, right? So it can't actually fit into an integer. Because integer actually stores only integer values, right? So it can't actually hold the double values. So this is the reason. But still, if you wanted to go ahead and convert it, then we can actually do it using the typecasting. All right. So I think this is clear now. Yeah, we are done with this wrapper classes. Now let's see a small topic as we have some time. Packages. So we know we create a project and then we create a package. And what's the hierarchy of creating the Java project? So Java project, you know, hierarchy is project, package, and then class, right? And within the class, we do have variables and methods. Each class will have its own variables and methods. This we know, right? Now, how do we actually convert? So this is the hierarchy, Java project hierarchy, right? Now we wanted to understand packages. So packages, there can be built-in packages and there can be user-defined packages. What are built-in packages? Java.util, Java.lang, all these are built-in packages. Built-in packages are all the packages which are already there in Java, right? So when you actually write the Java program, we can directly import these packages and use the classes which are defined in those packages. We have seen, we've been using the Java.lang packages, right? Likewise, we do have Java.util package as well. So we can use those classes by just importing Java.util. We can just say import java.util and we can use the classes defined in that package. Those packages are already defined by Java and it will have some util classes where each class will have its own methods and each method will perform some task for us or for some operation, right? So if we know what that operation is, then we can use those methods using those classes defined in those packages. Those are built-in packages which are already defined, right? So we do have other packages called user-defined packages. These are the packages we create. Like for example, we do create one package daily, right? Here under our project. These are all user-defined packages, right? Now, along with the packages, we can create sub-packages as well. So what are sub-packages? I can show you. Let me show you. So we can create sub-packages as well. Say for example, this is day 17, right? So I can create another package within it. So how do we create day 17 dot? I can just say test one, or I'll just say this is package one or pack one. Okay? Simply pack one. You can see pack one has been created, but this is within this. Okay, so just right click on this new package dot pack one. Now, if you wanted to see how this is stored, this is just a folder, right? So package is just a folder. How do we identify that? Right click on it. You can go to properties and you can see this icon, right? So location, it is actually available at this location. So in order to go to that location or open it in Explorer, just click on this icon. So that will be open and you can see here, right? So you can see this, all the packages which are we are defining daily, right? So you can see it here clearly, all these packages, right? Now, day 17, you can see pack one. We just created now, right? So that's a sub package. So within the package, we are creating another package, which we call it as sub package. That's possible. And that this is how the hierarchy is. So day 17, a package, it's a folder and pack one is a subfolder. That's how it is stored. But when we create that in Eclipse, we are calling it as sub package, right? Day 17 dot pack one. So this is how we can create the sub packages. So this we need to know as we are going to understand the access modifiers now. So access modifiers. We have been using public and default access modifiers, right? So now let's understand what are these. What do we mean by this access modifiers? We have even discussed this in the last session, but at a high level we have discussed, right? Now we'll see in detail, like we'll see an example also on each access modifier, right? So what's the scope? So let's understand. Okay, let me explain you. No, so once we create once we create the classes, right? So this it is treating it as a different package. So day17.pack1, it is just treating it as a different package. So, but we still created it in the same package, right? So when we create the class, this will be gone. So yeah, it's a sub package. Day17 is a package and day17.pack1 is a sub package. Now let me show you let me explain you about the access modifiers. We'll come to that regarding the sub packages. So first let's go through this. So I do have, what's the scope? Say for example, this is my project. This is the project, right? This is Java project, and within it, what do we have within the package? We do have the within the project, we do have the packages, right? Say for example, package 1, package 2, package 3, like this, right? So these are all the say for example, this is my package 1. This is package 2. We can have different packages like this, right? And each package, what it contains classes again, right? It contains classes. So class 1, class 2, class 1, class 2, and so on, right? So like that, each package will have its own classes. Let's say, for example, this circle represents the one class, right? All these are the classes. Again, each class will have its own methods, variables, and methods, right? Now, we wanted to actually see, we wanted to understand the access modifiers, right? So, if a variable or method, if it is private, then it can be accessed only within the class. Only within the class, it can be accessed. This is called private. So when we say a variable or a method is a private, then that is accessible only at the class level. At the class level, right? And when it is declared as default, right? So when it is declared, a variable or method is declared as default. So all the methods till now, we are defining variables and methods. So whatever we are discussing, whatever we are declaring till now, variables and methods, all these comes under package, right? So all these comes under default. And default, when we say the scope is only within the package. So within the class and also outside of the class also, we can access those variables and methods. So scope of the scope of default access modifier is across the package. We can say it is across the package. So within the class and other classes also, we can access the variables and methods. That's what default is. Till now, we have actually declared all the variables and methods by default. So by default, the access modifier is default. So you don't need to specify the default keyword, right? That's the scope of default. And what is protected? So we do have something called protected as well. So if you observe, so we do have private. I'm coming from least, more restrictive to least restrictive. So private is most restrictive. So you can only access within the class. Once you are outside of the class, you can't access the private variables or private methods, right? But default, it can be accessible only within the package. So within the package, if there are multiple classes, you can access variables and methods of one class to other class. That's default scope, right? So that's how we're been doing till now, right? So without knowing, unknowingly, we are doing that, but all those variables and methods are by default variables and default methods, which can be accessible only within the package. And what is protected? So protected is something like default itself. So it can be accessible only within the package, but there is an exception to that when the classes or subclasses of the, say for example, I have one class in P2, package 2, and it's a super class. And P1 has a subclass. Then subclass, meaning there's a class in P1 which actually is inheriting a class in P2. Then in that case, you know, so in that case, we can access the variables and methods of P1, right? So P1 is a parent class and P1 is a child class, let's assume, right? So in that case, what happens? So this is a parent, we do have, this is a parent class, say for example, and this is a child class, this is a child class, this is a parent class. So in that case, then we can actually access. So in that case, this is inheritance, right? So in that case, like if this can be protected, the protected variables can be accessed. So the protected variables or method can be accessed only when the class can be from other package as well, but has to be a subclass of the other first package, right? So only then this protected will actually be accessible outside of the package, or else it is same as the default, right? Only if there is an uh, inheritance concept, meaning like if the class which we are accessing from the other package is a subclass of the superclass in the current package, only then the protected will work. The protected will have the scope of accessing the class outside of the package. That's protected. We'll see that now as in an example. So in a few minutes. And what is public? Public is accessing variables and methods everywhere. So scope of public is across the project. Like in P1, you can use P3 class. In P2, you can use P1 class, like that. Across the project, you can use any variable and method at any place, in any package, in any class. So that's the scope of project, least restrictive. That's the scope of public, right? So we'll discuss this now. With an example, we'll see. So say for example, I have pack one, right? So now say for example, I will create two classes. I will create test one. I'll create test one and test two. First, let's start with private. Say for example, I have a method called M1, right? So I'll just say this is M1 method. This is M1 from test one, okay? All right, now we'll create another class where I'll call the class as test2, where I'm gonna create that in the same pack one, right? So pack one. Class, right? So test2, where I can take the main method. This is test2. Now I'm gonna create a object for test1. So this is possible, right? So I created an object for test1. All right. Now I'll try to access t dot a, right? So is this possible? And also I'm trying to call M1 method. So if you observe, we are getting an error here. So saying change visibility of, you can see the method M1 from the type test1 is not visible. This is because the variable and methods are defined in a class called test1, and the scope of this is within this class. So I can have another method defined here, which is private or public, and I can use this variable and method within those methods only, because that's within the class, right? But once I come out of this class, so even though that is in the same package, see, it's just another class within the same package, but still, as these are the variables and methods of private, so we can't access them outside of the class. So most restrictive is private access modifier. The field test1.a is not visible. So because it has been declared as private, right? So even the same goes for method as well. So as these are private, we can't access them outside of the class. So this is very much straightforward, right? So we can, the scope of it is only within the class. Within the class, we can define the methods and we can use these variables and the methods. But outside of the class, the private variables are, we can't access the private variable or private methods. Now, let's come back to the next one, default, right? Accessible only within the package. Now, say for example, the same thing, I'll just do a copy and then we'll just remove this. So these are default, right? So by default, you don't need to specify the default keyword. So you can even do it something like this, but it's not required, syntax error and tokens. So this is not required. We don't need to declare them as default. Why? So by default, these are called, these are actually default methods. So even though you do not specify the keyword default, these are default methods, right? So for default access modifier, you don't need to specify the default keyword. So by default, these are default. So you should not specify any access modifier. Those are default. So this is a default variable and this is a default method. So according to that, what should happen? Accessible only within the package, right? So within the package, they are accessible. See, the error is gone because both test2 and test1 are in the same package called pack1, right? So both test1 and test2 are in the same package and you can see the error is gone. Earlier, as the variables and methods were private, so once you are out of the class, so we are getting error. But this time, the variable and methods are default. So default, the scope is within the package. So test2 is also in the same package. So we can access the variable A and also the method M here, right? So this is about the default access modifier, right? So you don't even need to specify the default keyword. Now, let us come to protected. Let us understand protected. So say, for example, I do have the same variables with protected as access modifier. So protected. So even before going for protected, let's understand default itself. So default, the scope of it is only within the package, right? So we created a package, pack1, in day 17, fine. And we are able to access the default variables. Now, if I create another package, say for example, I'm going to create another package. Say for example, day 17 dot pack2. If I create folder, okay, I tried creating a folder. Okay, let's create. So even though you see it as a different one, but it's the same package, right? So it is just displaying as a day17.pack1, but it is still a sub package. Now I'm going to create another package where I'll say day17 dot pack2. And we'll just copy this test2 here. So you don't need to get confused. This is not a different package. This is a sub package. This is a sub package, right? So this is a sub package within day 17, right? So now I do have another package called test2. So we do have two test2 classes now. So test2 and test2, right? So or let's call this as test3, not to have any confusion, right? Test3. So this is my, or are you okay? Let's call this as only test. Now I do have another class called test, right? Now observe. So this was pack one, fine. This is from pack two, another package, right? Different package. Now see the scope. As this is default, what happened? So it is throwing error. Earlier, it was not throwing error, right? Because it was in the same package, pack one. But now we were in a different package and we are trying to access the test one, right? So we are trying to access the test one. It is throwing the error, right? So because test test one variable, so it is not even able to understand, like, right? So import test one. So even we import it, right? So it doesn't need it doesn't understand where this test one is coming from, first of all, right? So we need to import it. So we import it from pack one. So we have test one in pack one is what we said, right? Fine. Now, still we are getting an error, right? So it is saying, A, the field test1 is not visible. The method M1 is not visible because this is coming from other package and the default access modifier, what's the scope of it? It is only within the package, but we are out of the package now. We are into package 2. So if you observe, so this is the reason we are getting the error. So importing it is different, right? So importing, why we are importing this test1? As this is in pack 2, so it just verifies if test1 is present within the package. As it was not there, it was throwing error and it was suggesting us, do you mean test1 from this package? We said yes, then it imported that, right? So as this package is as this class test1 is in another package, so this test object, right, this t is not able to access the variables and methods. So it is very simple, right? So this is how you need to understand. If the package is different, right? So the default variable or default methods cannot be accessed. So earlier it was in the same package. So we are able to access the variable and methods. Now we are in a different package. If you observe, we are in pack 2. And now we are not able to access the variable and methods. This is because default access modifier is accessible only within the package. Now we'll go back to the protected, accessible outside of the package through inheritance. So how are we going to do this? So observe. So I'll just have this commented out. Just take a copy of this. And now observe. I'll extend this, extend test one, right? We are importing test one. Now see, test one. We need to create object test, right? So extends test one. So we need to create an object of test here, right? So test t dot a, right? So we are still getting error because we didn't declare them as protected. So now let's do that. I'll just comment this out. These are the default ones. Now, what we wanted to understand is, let's say, for example, I make this as protected. So these are protected now, right? Now, if you see, these are accessible. So earlier, so this was test class, right? So let's actually even have the test class here. So even we get this error, right? So you can clearly see that error here. Say, for example, this was a new test, right? So I created test object, but still we are getting error because earlier it was like, it was a default one, right? Now I'm just showing you this. So earlier example, what did we do? We created a new test and then we created an object of it. We are not able to access because those were the default method and default variables, right? Now taking the same methods and same variables as protected. We are taking same variables and same methods as protected. We are trying to understand it, like the scope of it. So how we are doing it now is we are trying to extend the class. We are trying to extend the class. See, test is a class, right? Within the pack2. Now we are extending the test1. So test1, we have to say which package it is coming from. So we said that. Fine. Now if you observe, so it is gone, right? So the error is gone. T.A, T.M1 is accessible. This is because we actually declared them as protected, right? So say for example, I just remove this. Then you get an error. See, the field A is not visible. The method M1 is not visible. So this is because they are default variables and methods which can't be accessed outside of the package. So protected also, if you observe, so even protected, if I'm not going to extend the class, so then we get an error. So protected is also same as default, and it supports an outside of the package accessibility only when we extend the class from the other package. So only when we extend, this error is gone, right? So if you observe, so when I do this, when I do not extend the test1, then even if the variable and the methods are protected, we get an error, right? Only when you extend the subclass, so we can access the class outside of the package. So we are completely in a different package now, if you observe. And we are trying to see the access of the protected variables and methods. And that can be accessible only when we use the inheritance concept. That is, when we inherit the class of the other package, only then we can access the variables and methods of that subclass, right? So this is about protected. Now, let's actually declare this as public. So public, the accessibility is like universal. Say for example, these are public. What does protected say? So protected variables and methods can be supported outside of the package as well, but you need to extend, you need to inherit is what it says, right? No, as these are public, these are not no more protected. So we can even remove this and this still works, right? So or what we can do is, let's keep protected as is. This is about protected. Now let's go back. Just enable this, right? So as these are public, now this int a and these are public now. So this has to be accessible. What does this say? A cannot be resolved or is not a field. Test1 is coming from pack1, right? Okay. And test2. M1 is undefined for the type test. Okay. These are again like test1, right? We need to create an object of test1. So you can see T.A, T.M1 are accessible as these are universal, right? So we did not even extend this class, right? But still we are able to access it. So this is all about public. So we don't, this doesn't have any restrictions. So it is least restrictive, right? So most restrictive is private within the class, default only within the package, and protected outside of the package, but only through inheritance. Only when we extend the subclass, superclass, then we actually can access the outside of the package as well. And public, we can access all the variables and methods everywhere. Everywhere in the sense we can access. See, this is coming from different package altogether, right? But still, even though we are not extending, we are not using the inheritance concept, we are able to access this variables and methods from other class. Is that clear? So there is no lower one here. Now you can see, right? So all are organized correctly now. So pack1 has two classes and pack2 has its own class test, right? So you can see that clearly. Any questions? Is that clear? First of all, access modifiers. So anyway, when creating the Selenium scripts, we are going to have mostly as public. But if you wanted to restrict, so developers usually do this, like they actually define the variables in a private mode when they feel that they wanted to secure those variables and methods and other access modifiers. But most of the cases, we actually have it as public. But in the interview point of view, these are very important. What are the different access modifiers? So what's the difference between protected and default? So what happens when we declare a variable or method as private like that? So is that clear? Are you able to get it? Okay. All right then. So in this session, we discussed about, we started with wrapper classes. We understood like what are the wrapper classes and what's the use of wrapper classes. We can convert them from uh, the primitive data types to objects using the wrapper classes. And also wrapper classes has its own methods. Which we can use it for different, performing different tasks, right? And we can even convert the object to primitive as well. So that we actually call that as unboxing, and primitive to object, we call it as autoboxing. And we have seen examples on that, and we have also seen how to convert the data, how to convert data from one data type to another data type, like mostly from string to primitive data types and primitive types back to string. We have seen that, and we have seen a small example on how to actually convert from one number type to one number data type to other number data type, right? And we also understood what are the sub packages and what are the different access modifiers available, right? So you can stop here, and if you have any questions, you can ask.